Hi everyone, I'm Antonio David Masegosa. I work as a researcher at the University of Deusto, and in this tutorial I'm going to show you one of the key outcomes of the SOTERIA project, that is the SOTERIA Safety Intelligence Platform, whose objective is to support road safety managers to turn analytics into actionable urban decisions. Let me start explaining you the main motivations behind the design of the SOTERIA Safety Intelligence Platform. During the first stages of the project, especially during the co-creation workshop, we identified different issues related to the management and analysis of road safety. The first of these issues was that the analysis of road crash hotspots relies solely on accident databases, which limited the scope of the analysis and the type of factors that could be taken into account. Apart from that, we also observed that this process was not automated, which also resulted in a low frequency of update. Furthermore, the causes behind those hotspots were identified through physical inspections, which added extra time and extra human resources for that task. And finally, we also observed that there were no risk estimates for areas where no road crashes have occurred. And all the experts and stakeholders involved mentioned that there is a strong need to move from reactive road safety management to a more proactive road safety management in which we intervene before the road crashes occur. To move towards a more proactive road safety management, it is important to observe that road crashes are the confluence of risk and bad luck. A road, a cycle path, or a location with no severe crashes or fatalities is not necessarily safe. And this is very well illustrated by the so-called safety triangle that we can see on the right part of the slide. And this triangle establishes that for every crash with severe injuries or fatalities, we have 10 crashes with serious injuries, about 30 with minor injuries, 600 near misses, or around 30,000 as safe actions. What it happens is that these three here are the ones that are reported by the local police officers, but these two here, the near misses and the unsafe actions, are not reported anywhere, but they can provide a lot of useful information for this proactive road safety management, because they can give us relevant clues or insights about high-risk locations even before road crashes happens, as I said before. So with these ideas in mind, two of the key research questions that we posed for the development of this platform are the ones that I show in this slide. So the first one is, can we identify near misses and unsafe actions using novel data sources? And the second one was, can we identify potentially unsafe road sections or intersections for vulnerable road users by learning from those locations with reported crashes and using also novel data sources? In this slide, I show you some of the main data sources that we use to answer the research question that I mentioned in the previous slide, and also to build the SOTERIA Safety Intelligence Platform. And these data sources goes from more classical ones as infrastructure data or police accident records to more novel data sources such as near misses, connected vehicle data, or cellular network data. Let me show you two of the most relevant examples of the utilization of the previous data sources for the development of the SOTERIA Safety Intelligence Platform. The first one is related to the leveraging of connected vehicle data to identify near misses and unsafe actions. So let me first introduce what is connected vehicle data. So this data encompasses the information that is produced by vehicle equipped with internet connectivity and also onboard sensors that can provide information related to the vehicle's locations, speed or acceleration. So in this project, this data was used to detect harsh events such as strong brakes or sharp turn left or turn right that can serve as a proxy for near misses and unsafe action. And actually, in these two plots on the right, we can see a strong correlation between the road crashes and also the location of these harsh events. The second relevant example of the utilization of the previous data sources was the inference of explanatory variable for the safety analysis of vulnerable road users. And more specifically, for the estimation of travel demand at the road section level by fusing novel data sources such as cellular data or micromobility data. And this was one of the key innovations of the project, because we were able to analyze and estimate the number of crashes per exposure level for different road user types. So for example, we were able to estimate the number of crashes per 1,000 private vehicles or per 1,000 micromobility users or motorbike users at the road section level. After the two previous examples, now it's time to give you the whole picture about the key functionalities that we are able to provide through the SOTERIA Safety Intelligence Platform. So the first one is related to the identification of road crash hotspot, in which the tool is able to identify automatically hotspot according to predefined rules for different severities and also for different road user types. Another key functionality is the visualization of potentially hazardous locations that are based on a high frequency of harsh events derived from connected vehicle data. The third relevant functionality is related to the display of crashes by exposure level, as I mentioned before, and we are able to do that for different vehicle types at the road section level. Another functionality aligned with the previous one is the display of trip frequency, also at the road section level for different type of users and also for different times of the day. Apart from the previous one, another relevant functionality was the visualization of road crashes. We will see later that the user is able to filter them by location, user type, cause, severity, and type of day. And finally, we have one of the most novel and relevant ones, that is the prediction of road crash risk, that is provided through the utilization of both AI and classical predictive models. Before showing you a demo of this platform, let me give you very general ideas about how this tool works internally, and for that I'm showing here the general architecture of the system, and in the next slides I will briefly describe the working and the purpose of each of these components. The first relevant component of the platform is the so-called Safe Mobility Data Space, whose objective is to store and manage all the raw data collected in the project, such as road crashes, connected vehicle data, travel demand data, environmental or infrastructure data. And the idea is that this component will keep this data in an harmonized way in order to facilitate their use by the different components. The harmonized raw data stored in the Safe Mobility Data Space is extracted and processed by another module that we call the road crash data processing and analyze module. And basically the objective of this component is to analyze these different data sources in order to derive information related to vulnerable road users safety, such as road crash frequency and severity at both section and intersection level, and also the identification of road crash hotspots according to predefined rules, as I mentioned before. One of the pivotal components of the SOTERIA Safety Intelligence Platform is what we call the label graph, that is dedicated to storing within a database information related to sections and intersections using a graph-based oriented data structure, where intersections are modeled as nodes and sections as arcs. Then these nodes and arcs have properties associated related to infrastructure, road crash data, hotspot identification, driving behavior, and some other information that is produced by the different components. The information stored in the label graph is then utilized by different methodologies related to accident and demand predictive analytics that are actually the most novel methodologies included in this platform. And for example, these include classical and AI-based models for road crash predictions, model to estimate travel demand for different vulnerable road user types, as I mentioned before, and also interestingly a set of explainable AI methodologies whose objective is to improve the trustworthiness of the prediction made by the AI-based models. Apart from that, it's also relevant to mention that this platform is able to interact with external components. So for example, other components can provide information to the safe mobility data space or can consume information from the label graph through a dedicated REST API. And finally, all the information produced by the different methodologies, components, and modules is provided to the user through an interactive dashboard whose objective is to give a holistic view to the road safety managers about the safety of vulnerable road users in a specific area. And I will continue this tutorial with a demo of this tool. Starting with the demo of the tool, the first thing that the user will see will be the login page. Then it will type the login and the password, and then it can enter the tool. So once that it enters, the first thing that it sees different plots and statistics related to the road crashes in the specific area in a selected year that can change in this menu here. Okay, for example, I can select 2024, and this will update these plots about the total number of accidents and so the share of accidents for different level of severity or user type of, for example, weather conditions. Okay, we are watching here the results related to the case study of Madrid. That is the main case study for which we developed this tool. So we'll change now again to the 2020. So the first one, as I mentioned before, is the one related to hotspot. So if I click here, what I will see is the location of the different hotspot in the area selected that, as I mentioned before, here will be the Madrid city area. So here the user can see the hotspot for different years. So 2023 or coming back to 2025, the user can then show this hotspot for different type of users. So for example, pedestrian, cyclist, or motorcyclist. It can also filter them by severity between light, severe, or mass, and also it can filter them by type of segment because we differentiate between by type of hotspot, because we differentiate them by segment or intersection. For example, these are the ones related to intersections, or these are the ones related to segments. So, for example, if I filter them by mass, that are the most relevant ones, and if I click in one of these hotspots, the tool will take me to the specific location of this hotspot, and then I will be able to see all the accidents that have happened in this location in the selected year. So, for example, if I put my mouse over this point, I can see the specific characteristics of this accident. And I can see more details about these road crashes if I click on the view accidents. And another interesting feature is that if I switch to the satellite view, then I can see better details of the characteristics of the road infrastructure in that location. So, moving back to the general view, so let me change. Another of the interesting features is that I can visualize this hotspot for specific districts of the city. So, for example, if I click here, I will see the different districts in the city, and if I click in one of them, then the tool will take me to that specific district. And then, as you can see here, it filters all the different hotspots for this location. And if I show the charts, this will give me statistics about the hotspot in this specific location. And if I change to different district, this statistic will change according to the selected district. I will now move to the travel demand view. In this view, what the user can see in first place is what we call this number of crashes per level of exposure. And this can be displayed for different type of users, as I mentioned before. So here we are seeing this number of crashes by level of exposure for private cars, but we can also display these statistics for micromobility users or for motorbike users. And then, for example, if I selected a passenger car, and if I put my mouse in one of these locations, I can see more details about, like, for example, the total number of crashes or the crash rate. That is, as I mentioned before, the number of crashes per thousands of vehicles. Okay. And another interesting view of this functionality is this travel demand. It displays the level of demand, the frequency of trips at road section level for all the road section that we have in the city area of Madrid. We can filter them, for example, for different, let's say, levels of frequency. So I'm changing this now to up to, let's say, from 10,000 vehicles or more, or I can reduce it even to 5,000 vehicles or more. And then if I click of one of these segments, for example, let me click here, and the tool will show statistics related to this specific segment. For example, to the total demand segmented by type of vehicle, what is the profile of the demand by the different hours of the day, or also, very interestingly, what is this demand segmented by type of vehicle and gender in this case. So I will move now to the dangerous location view. As I mentioned in the presentation, this view is related to location that can be potentially hazardous or dangerous because they have a high frequency of different types of vehicle harsh events, such as strong brakes and sharp turns left or turn right. Because during the project, we realized that there was a strong correlation between location of hotspot and a high concentration of this type of vehicle harsh events. So here, for example, we are displaying some of these locations, and the tool gives the opportunity uh, to overlap these locations with the current hotspot to see if these locations correspond to current hotspot or to locations that are not identified as a hotspot, and then it will deserve better inspection because they can be potentially dangerous. So I will move now to the other view that is related to the visualization of accidents. So in this view, the user can see the location of accidents in the selected year. In this case, in the city of Madrid, and also some statistics related to this accident, like such as the total number of accident or road crashes, the segmentation by involved user, by vehicle or user type, by cause, or by age range, for example. And it can also compare the selected year versus the previous 3 years. So these road crashes or accident can be filtered by type, by level of severity, by user type, or by the type. So for example, I will choose those for pedestrian, or for example, I can choose those that involve some fatalities. This visualization can also be filtered, as we saw before, by district. So if I select one district, then the tool will take me to that specific district. And then the statistics will be related to this district, and they will change if I select different districts. So I will move now to the final view that is related to accident predictions. In this view, the user can see the results of the different models that we have to predict a road crash risk at section and intersection level. So in this case, we are displaying the results of the AI-based models that predict the number of accidents at intersection level. And for example, we can filter this result by risk or severity. So I will choose those ones with a very high risk that are more relevant. And I can, for example, filter them depending on whether this location is already a hotspot or not. So I will filter them for those that are not hotspot because they are the most relevant ones, because it means that this location can potentially become a hotspot in the upcoming year. And then the user can inspect them, for example, by, for example, changing, as I did before, to the satellite view. Okay. So, as I mentioned before, apart from the AI models, we have generalized linear model that predict a specific risk score for the sections in a city. So, for example, the user here can see this risk score for specific users that in this case are cyclists and pedestrians. And with this, I finished the demo of the SOTERIA Safety Intelligence Platform. Before finishing this tutorial, I would like to emphasize that this is a collaborative work among different partners in the SOTERIA project. And here you can find a list of the partners that have participated in the development of this very interesting tool, and you can also find the main contact person for each of them. If you are interested in having more information or more details about this tool, about the different components or the result that we obtained. You can scan the QR code that you can find in the right part of the slide, and this will take you to the project Zenodo, where you can find different data sets or deliverables describing these components. So I hope that you enjoyed this tutorial. Thank you very much for watching it.